All right, so for this lesson, we're looking at review for factoring. We have a few things to go over. The first one is that we always do GCF first. To do the GCF, you have to find what factors they have in common. You can use the multiplication table that's on the table in the classroom, but for 32, we can divide it. I'm gonna do a factor trees on the side to make it easier. For 32, it's like 1 times 32, 2 times 16. 3 doesn't work, but it's 4 times 8. 5 doesn't work, 6 doesn't work, 7 doesn't work, and then we're back to 8. And then for 24, we do the same thing. We do the factor tree for 24, 2 and 12, 3 and 8, 4 and 6. And then we look at the numbers, the biggest number they have in common. In this case, we have an 8 in common. Ideally, you don't have to do the factor trees every single time you do GCF. By now, I'm hoping that you're comfortable with the multiplication table and that you can do all of this without having to write them out. But if you have to write them out, please go ahead and do it. So when I divide by 8, my 32 divided by 8 gives me this 4. So the 4 goes here. And my 24 divided by 8 gives me 3. So 3 goes here. And I left some spaces because I still have to go back and deal with the x's. For my x, on the first one, I had 4 of them. On the second one, I had 2 of them. So we're looking for what they have in common. They have at least 2 in common. So I take out x squared. I have 2 left for the first term and none left for the second term. Do not forget to bring down your minus sign. And that's how we do GCF. This is the long way. I try to break it down as much as possible so you can see it. But ideally, you can do all of that without having to write it out, especially with the x squareds. Like normally, we could just subtract the exponents and you get the right answer and you should be fine. Now, we're going to move on to X puzzles. Again, whenever you start a question, the first thing you should do is check for GCF. My 5 is fairly simple. It's just 5 times 1. And since you can't divide any of these numbers by 5, there's no GCF. So now we can move on to the X puzzle. A, B, and C. You multiply A times C on top. B goes on the bottom. Oops. A times C is 40. B goes on the bottom. And then you do the factors of 40. What numbers can we multiply to get 40? 3, 4, and 10, 5, and 8. But because the bottom number is negative, these have to be negative, and you're trying to see which ones add up to 22. This is 41, this is 22, this is 14, and this is 13. So this is the one that works. We just have to make them both negative. So they add up to a negative 22. Now that we have that, we have to divide by A all the time. When we divide here, we cannot simplify, so the bottom number goes in front of X. When we divide here, we get negative 4. So there's my answer. One thing I do want you to be careful is if, when you do the X puzzle, you end up with something like 6 over 4 and, 1 over 4. This one you cannot divide, but you can and must simplify. If you don't know how to simplify, you can do it on the calculator, alpha, y equals 1, or you can do it on decimals. But when you simplify it, it becomes 3 over 2, and then we rewrite it. So this would be 4x plus 1. If you do not simplify the fraction, the answer would be incorrect. If you write 4x plus 6, it will be marked incorrectly for this question. So you have to fix it. You have to reduce the problem all the time. The numbers all the time. Now, difference of squares. I'm not sure if we talked about difference of squares in class because I feel like we skipped over it maybe. We did it just as an X puzzle. So for this question, I do want to stress that, yes, you can do it as an X puzzle. Just make sure that you are aware that your B value is 0. Like A is 1. B is not there because there's no X. And C is negative 16. So here's my X puzzle. What numbers can we multiply to get negative 16 but add up to 0? The negative 4 and positive 4 works. We don't have to divide by the A because A is 1. So we get X minus 4 and X plus 4, which works wonderfully. The only issue is what happens when we get to bigger numbers and you have to deal with more work. So the difference of squares, the idea is that you have two numbers that are being subtracted and they're both perfect squares. Here's how we check it that they're perfect squares. X squared is x times x. 16 is 4 times 4. So whenever you multiply something twice, you get, and you get that number, the 16, that's how we know it's perfect squares. To factor those, you have two factors, one with a plus sign, one with a minus sign, kind of like we had here. And then you go back and find the factors. So for x squared, I had to multiply x times x. So for a, I would have to multiply a times a. And for b squared, I had to multiply b times b. So for the 16, I had to multiply 4 times 4. Let me show you how it works with the different numbers so you can kind of get the hang of it. Let's say I have 9x squared minus, it always has to be a minus sign. Let's do 25. So again, the answers would always be a plus and a minus, one parenthesis with a plus, one with a minus. And now for the 9. To get 9, I had to multiply 3 times 3. To get x squared, I had to multiply x times x. For the 25, I had to multiply 5 times 5. And so that's how I can factor using difference of squares without having to do the x puzzle. You could definitely do the x puzzle for this problem, but you have to multiply 9 times 25, and that's just a lot of big numbers. So difference of squares rule works a lot easier and faster. Now, to combine it all, for this one, notice I have two terms. So normally I could try and do the x puzzle or difference of squares, but first we always check for GCF. So we have 3 and 27. That means they're both divisible by 3, and they both have x's. So I get 3x as my GCF. It's part of my answer. When I divide by 3, I get 1. When I subtract the exponents, I get x squared. When I divide by 3, I get -9. When I subtract the exponents, I get 0. Now, we have two terms, which again, we can do the x puzzle on, or we can do difference of squares. For x squared, sorry, you have to have a plus and a minus sign. For x squared, we had to multiply x times x. For the 9, we had to multiply 3 times 3. So that's how we get my answer, my actual full answer for this problem.